which are related by A. What is the meaning of related by A? X or A. So how do I read this? X is related to A, or A is related by X. Okay. So you have to look into all the elements of this kind which are there in the first element of the ordered pair. You have to check for all these elements. Okay. Which are all the elements which are related to A. Then equivalence class of A is defined as A bar, or within the big bracket A, or R of A. You can read it as equivalence class of A. The equivalence class of A are called as set of all elements X from A such that X comma A belongs to R. What is the meaning of X comma A? X is the element taken from A which is related to your class. Okay. So such elements you have to fetch from the relation, then group them as a set. We'll see an example here. Let us consider a relation R on the set A. We have to start finding the equivalence class of all the elements. So for example, equivalence of class 1. So 1 should be in the second place of the set. Where and all it is there? Check. Okay, look at this. Now this is in the form of X comma 1, correct? What is X? In place of X, you have 1, right? In place of X, you have 3. So that means 1 comma 3. These are the two elements which are related to 1. Therefore, equivalence of class 1 can be written as collection of the elements 1 comma 3. That is set. It's a set of elements 1 comma 3. In similar way, you have to find out for equivalence class of all the elements. So when I go for equivalence class of 2, look at 2 in the second position. 2 is here. Anywhere else 2 is there? No. So 2 should be in the second place. Only one possibility, this. So 2 comma 2, where this is my equivalence class. So which element is related to this 2? Only 2, right? Therefore, answer is 2. Moving on to next example. The next example is equivalence class of 3. Look at an element where this 3 is in the second position in the set. Okay. So that is 1 comma 3 and 3 comma 3. So in this, I am trying to find this 3 as my equivalence class. Okay. For that, 1 and 3 are connected. Therefore, 1 comma 3 is taken as equivalence class of 3. Any doubt here? Okay. Moving on to partitions. In the similar way, there are several problems in the textbook. It can be, here I had taken an example of relation which is of the form ordered pair. There could be diagram could be given, matrix could be given to you for finding the same thing. Next is partition of set. So what is meant by partition of set? Let A be any non-empty set. That means there will be at least one element in that. Suppose there exists non-empty subset of this form. There are k number of elements A1 to AK of A, such that the following two conditions holds. So what is that condition is? Your set, original set A, is union of all these sets A1 to AK. Nothing but A can be written as A1 union, A2 union, etc. union AK. First property. The second condition says that any two of these A1 to AK should be disjoint. What is the meaning of disjoint is? there should not be any common elements among this k number of sets. Okay, that means when you take any ai intersection with any aj where I and j are two different sets, then it should be null. There should not be any common element between these two sets. So that means all these are disjoint, and when I make all union of this, I should get back my original set A. Okay. So then the set P is your partition. Okay. This is called as partition, which is a collection of all the subsets which are distinct. And if we make union of this, I should get back the set A. Is called a partition of A. Also, A1 to AK are called as blocks or cells of the partitions. You can look into this figure here. A1, A2, A3, A4, A5, A6. There are 6 blocks here, and each there is no common. This is something like your Venn diagram, right? You can just recall Venn diagram. Here all are distinct. If I want A back, I have to do A1 union with all the sets A6, and if I take any pair here, say for example A1 and A2, it's null. Okay, it's all disjoint. In case if you have written like this block, then there is a common element here, right? Then this cannot become a partition, proper partition. Therefore, you have to always look into disjoint blocks. This is one disjoint, this is another disjoint, all are disjoint blocks. Therefore, you can call this as a partition. Is the definition clear? So moving on to example, set is 1, 2, 3, 4, 5, 6, 7, 8, and its following subsets are like this. A1 is defined as 1, 3, 5, 7. Then A2 is another set, 2 and 4. Then A3 is 6 and 8. Now you can observe here, each one is distinct. Yes, there is no common element among all this. And if I make union of all these three, yes, it is going to obviously give us A itself. Therefore, you can call P as a partition of A. You can write partition as P is equal to A1, A2, A3. It's a collection of blocks, collection of subsets, other subsets. And if I take one more, look at this, one more, which is A4 of the kind 1, 3, 5. So if I make P1 as A2, A3, A4, so in 3 and 4, look at this, A2 I have taken this, A3 I have taken this, and A4 I have taken this. So from all these three, will I be able to get A if I do union? Yes, 1 is there here from this. I am just going to write all these elements together. 1, 2 from the second set, and 3 from the fourth set, then 4 from the second set. Next, 5 from the fourth set, 6 from the third set, 7 is not there, 8 from this set. Okay, so it's what is missing here? The 7. The element 7 is missing here. Okay, therefore this cannot be called as partition because one element is missing. In first property or the first condition is failure here. Either first condition might be failure or the second condition might be failure. We will not be able to say whether it is a proper partition for the given set. Any doubt here? So with that, we are moving on to one problem. I want everyone to get involved in this solving the problem.